And this is known as the Harry Rosen Project. Made with respect. 100% recycled material. Nice, whatever. We're in the shop, and today we have an interesting project. This is from an espresso maker, and what happened was it started leaking. So I don't know exactly where it started leaking, but there's the mating surfaces along here. Probably there, leaking a bit, you could see. It looks like a heater element in there, right? See, heater element. And the water in and out is through here. In and out, or out and in. Probably in and then out. So anyways, a buddy of mine started taking it apart for a buddy of his. And what happened was there's a 5th bolt right there and it snapped. So then he tried to drill it out, and he did drill it out a little bit, the bolt, and then he used an extractor and it snapped in there. So then he figured he would drill from the other side, right? And try and get it out, but then it just deflected off of the extractor and went there. So here, I don't know, I don't have any tungsten, like carbide stuff, like really hard stuff to just bore that out on the milling machine. So first step, I guess, would be to split this in half and see what we see on the other side, in the inside, right? And just take it from there. See if it'll actually even come apart. Let me think here. It might not, because it has to slide on this, and this bolt would, I guess, mesh up with there. Oh. Maybe that's not a good idea. Maybe we'll just use a little bit of the chisels, right? We'll try to hammer that a bit to get out some of that material. He said that it goes in about this much, so another option is to just leave as is, clean up on this side, right? And then with the milling machine, and then I'm not sure this has to be flat. That's the problem. Maybe we'll mill out that and make a little flat spot so that the head would be countersunk, right? This one's a little bit of a challenge. So we put in the vise here, and I don't know how it's made up in there. That's another issue, right? I don't know if the diameter of that screw or bolt. I don't know. I think the chisel method might be good, just to try and chisel it out. Gave it a couple of smacks already, but I don't know. He said the extractor went in there really deep, so like a good bit, like this, 1/4 of an inch. That really doesn't make sense either. I don't know. Okay, so this is what I'm going to try and do. I'm going to just make a little sanding disc here, like this, to size. Put it inside here, clean up that hole so I can use what's left of the existing kind of circular surface to center it up in the milling machine. Once it's centered up in the milling machine, I'm going to try and just bore it down slowly with some drill bits, and just hope for the best. Hopefully the extracting screw that he used, the extractor, is made out of cheap stuff and not real carbide. So, or just a cheap kind of version of whatever metal, and hopefully it's just drillable, because I'm thinking if once I start chiseling around there, I'm going to lose my center here. I'm not going to be able to locate it, so that's what I'm thinking, just to try it out. Okay, we're just using some end mills, and just trying to center it up like that first. Right, just eyeball it, and now we'll get out the test dial indicator, I think it's called. Okay, I think I pretty much got it. Oh, it said roughly 0, but remember, if I just move this around just with my hand, you know, you can see I'm just pushing some lateral force on there, right? So it's like a 5 thou. Oh, if you let it go, then goes up to, see it? Pretty centered, I would say, because I can't go, you know that it's damaged on this other side, so I can't go all the way there. But within three parts of the circle, right, of the quadrants of the circle, it's, let's say, I don't know, within, I'd say about 4 thou. Okay, so I don't have a DRO, right? So I just marked off the 0, row B, because I might start playing around with these, right? So I mark it off like it has to approach from that side, right? For the backlash, right? 0 there, and likewise has to approach from this side, and then I'm right on. Okay, so in case I want to move it around, I might want to actually drill beside there where it's already opened up, and then I don't know, we'll try and see if we can pick it out. It's a very, this one here is a very, I don't know, I can tell you that. Okay, I'm gonna first try with the center drill and see what happens. Put it on this. See, it's pushing it over, right? No good, and likely puckered that up. Okay, so we've moved it off to 100 thou, right? Away from the center. You can see it there, it's going into the hole that my buddy did, and now there's a Dremel bit there, and hopefully there's a little bit of diamonds on there. And it's a little bit angled, right? It's a dovetail, it's a small dovetail, and I'm going to try to carve it from the side and lift up, okay? Not lift up really, but carve it from the side. Just try to break up that carbide extractor. Do that, we're gonna play with it and see how much I can get out. Basically, I'm going in 5 thou increments and cutting the side of it there. See it? So I'm just gonna load it up for 5 thou more. And just I'm using that as an end mill. I know it should be spun very much faster, but just gonna try to cut the existing bolt, right? Not the extractor, just to make an exit way for the extractor with the chisel. See if that will work. So recap, I'm approaching the center, right? Because you know, we got another 10 thou to go, right? And I'm just cutting it, right, with this cutter like that, just going up and down, and I'm going to try and just make an elongated cut along the bolt that we want to extract, and hopefully I'm cutting into that carbide, and hopefully this feels still sharp. So yeah, I'm only spinning it at 500 RPM. I'm cutting slow though, right? So we'll see what happens. We're going to try and bring it to the center and maybe beyond, and then try and drill again with a center drill, right, or something else. Here's another 5 thou. Now we're well beyond center, so I want to see what happens if I can maybe cut right through it. I don't want to go too much, right? Well, obviously not too much, but I can get that extractor cut in half. It'll just fall apart. Beautiful. 5 thou. Now I can bring it back to 0. Oh wow, that felt good. Oh yeah, oh yeah. Oh, it feels like the extractor's been cut right through. So let's bring it back to 0. Let's see how that sounds. Bring it back to 0. Remember, you gotta take out the backlash. So I'm approaching there, and there's my 0. So there's center. Let's see, it should just fall right in without any, yep, and it does. So I cut right through that thing. Wow, okay, so this method is somewhat working. Sorry. Kind of still cutting. Hey, don't squint. I'm trying a 332 just to try to see if I can go through it. Oh no, it deflects it. Wow, look at that. Let's see here. There is a hole there, so I'm thinking just go with end mills. I'm gonna go with an end mill. Let's see what kind of end mills I have. Okay, June 24th. Thank you, Mark, my supporters. Let's see what kind of end mills I have here. Amazon specials, which are very much appreciated. So let's go with a, let's see what size this one is. So let's try 3/16. That's 6/32. Let's try something smaller if I have it. So we'll try a 4/32, or also known as a 1/8, right? Let's go with that. Okay, so our 1/8 doesn't do very much. It kind of bottoms out, right? And let's go a little bit thicker. We'll go a little bit thicker with that. Let's take this thing out. I'm gonna see what it looks like, because it's like I can't really see from this angle here, right? I gotta recenter it. Oh, wow. Okay, good, we're good. See the hole straight through there? Starting to look good. I know it doesn't go straight through, but we're gonna clean that up. We're gonna see what we can drill there. It's deflecting the 1/8 drill bit, right? I don't have a long end mill. Maybe I'll have to buy one, or because I'm locating from this face, putting it down like this. So this face, I don't want to start drilling in from this side, because that hole is not located likely in the center. Maybe it is. So we've taken out one of the cap bolts here, and my buddy said it was exactly the same one here. So I'm gonna go with this size here. And basically what we're gonna try and use here is like a carbide die grinding deburring tool. If I can find them. I know I had it. So, and see, we've pretty much hollowed out the hole, hollowed out a hole into the center, and actually, as you'll recall me saying, I went over center here. So we're gonna true this up, locate it in the center again on the milling machine, and we will try and use one of those deburring or slash die cutting carbide bits just to kind of bore it through. Either that, or I'll get an end mill that's the proper size. I'm pretty sure I removed all those bits of metal. Let's see here. There are some threads. I see threads there, so that's promising. Anyways, sorry. I removed some of the, or most of, or all of the carbide extractor tool, right? So I think we're in good shape here overall. I've just been measuring up. Of course, batteries are low. When you need it, batteries are going to be low, right? So that's typical of these things here. So you always just have extra batteries. It's not rocket science. Okay, we're going to try to break right into the nitty-gritties here, right? So it looks like you look around here. Oh, by the way, here are the gaskets, or the O-rings. Anyways, put them in a safe spot. You look around, and how you gonna break into the nitty-gritty? They don't give you any place to open it up, right? Like to wedge it a little bit, right? So you look around, then you go bingo, baby, right there. Let's see. Hopefully she'll do it, right? Just come in here like this. My God, we are not going to get in there. Of course we're not. Great. So the screw shouldn't go right through. All right. The other way to do it might be to screw this tap bolt in a good bit and then just tap it, right? So you'll push that part down, right? So let's see if we can do that. But even that, it's like somewhat dodgy, right? A good bit, right? We're talking about, we need some threads for that, right? So try a little bit here, a little bit of tapping. So I'm trying to hold it from the top, right? But there you go. So she got a little bit of a crackation along the mating surfaces. So we'll try this out a little bit more this way. It's probably the best way. All right, so and we have to hold it from the top part. Well, it doesn't really matter where you hold it from because you're imparting a, a nice impact, right? So, well, it's better to hold it from the top part if you can, right? That's what you do. So, as you can see, we are starting to get into the nitty-gritty. Now, why we wanted to get into the nitty-gritty is because we just want to take out this bolt, really, and see what's going on, right? And once we take out the bolt, if we can just clean it out a little bit, maybe with a tap, then everything's honkadory. All right, so let's just, there you go. Nice. Now remember what we're doing here. We're this bolt snapped, so we're actually dragging it, and as you can see, it is. Oh, you know what? It's loose enough. I might be able to just pull it apart. Let's see here if I loosen these guys up. Oh, I got the tripod for the camera too. It's a little bit steadier. Okay, you'll see that there's even dowels to align this thing so precisely. I don't know what the heck these Italians think. I'm assuming this is made in Italy. Whatever. Italians make espresso machines, period. So I don't know what the hell these Italians think they are doing, because like you need all these alignments, like alignment, dowel pins, right? Dowel. It's like, it's a little bit overkill. Okay, so the gasket is on the inside, right? So we're not, this is a-okay to just lever here. There's no sealing surface here, no sealing surface here, and no sealing surface here. Okay, and now we, Jesus, what the heck is holding it? I think the rubber is holding it. It's vulcanized to the, let's see here. Oh, you know what's holding it? The bolt. The bolt there is holding it, right? The bolt that we're trying to extract, so. And as you can see, the extraction bolt was holding it still. So now let's see if we can, wow, look at that. There is a sealing surface there. I don't know how. Wow. Okay, so now we see that the hole is sealed there, right? It has to be sealed, and it is sealed right there, unfortunately. And Buddy, you see here how he drilled into it on the side. He elongated that hole, and here's still the bolt that I have to take out. Now I'd like to bore that bolt out, so I need to locate on it. So
I'm going to use, before I just try grabbing with a vice grip and turning it, which will screw everything up anyways, right? It's not going to have the force to do it. I'm going to locate it in the milling machine and locate from the outside in the roundness of the existing bolt, right? Because how else to locate where to go to drill? And we're gonna bore through it, because I definitely have the end mills this long to go through it and to bore it out. I'll be them in standard sizes, but I do have them. So they have to go up to, I believe I said 6mm diameter, right? So, well, not 6mm really, but whatever it is, very close to it, right? Because there's threads, so it's not 6mm. Whatever it is, it might be 5mm point something, right? Or 5mm diameter. Okay, we're just gonna cut off the head of this, because it's all nudgy there, so I'm just going to trim it back, like maybe here. Yeah. I need a new saw blade here, because it's... Anyways, I'm just gonna cut it here. I'm gonna cut it off. This saw blade has seen better days, so there's like no teeth here, and then teeth, and then yeah. Okay, we'll just clean it up a little bit more than what I've already cleaned it up. Problem is that the fail test indicator is going to go inside the thread, so it might be a little bit hard to locate it in the center. Maybe I can put a nut on there. I'm not sure, but a nut might help me, right? Because I can locate the nut, right? If the threads are good, I should be able to put a nut on there. 6mm nut. And then I can use this to help me locate. Use the outside of the nut. Let's see if I can do that. Okay, that ran on there pretty good. So now I can use the outside of the nut to locate it, right? Yeah. Okay, so I roughly eyeballed it, right, center, like that. Now we're gonna get into touching off the corners here of the nut and center it up. Okay, without going into too much detail, you know, we got close enough, kind of. I think it's within, well, it depends where your arbitrary zero is, but that's off by 1 thou. Then here we go, see that's a plus thou off by 1 thou. So minus a thou. Then there's one that kind of goes like almost 3.5 thou, let's say. Then this one goes, see, this one's the worst one, but it goes like plus 4 thou off. So I think we're pretty good. We're pretty good there. We're gonna go with that. Okay, now to get that zero, we approached from this side. So put a circle there. And to get this zero, we approached actually from this side. So yeah, so now you can be like, yeah, I can find zero where I'm saying it's zero. Actually, let's see here. Yeah, we're good still, we're good. Okay, there it is, that's the center, centered up. I'm gonna just take off that nut. I'm gonna take off this nut and I'm gonna just bore right through. I've locked up the dovetails and time to just go with the 3/16, which is close to almost 200 thou. And it's moving the bit though over, so that's the problem. I'm gonna try and cut very slowly here. So in that case, let me engage my slow cutter. There we go. Now we're cutting very slowly. Right? let the cutter do the work, right? Oh, you see it move over, right? Well, we're just gonna let the cutter do the work, so I'm gonna just cut very slowly in. This is the moment kind of truth. That came out. Okay, let's see. Let's see what we did. If I got it right in the center with a 3/16, we're gonna even, we should see threads. Should see threads. And bingo. There are threads. Believe it or not, you can't see it. There they are. See the threads? So we got it pretty much in the center. Let's just pick out what's nasty. We're gonna try and pick out what's nasty, and then see if she'll receive a 6mm cap screw. It looks kind of good. Okay, one of the reasons I got a milling machine was just to do this type of work, but like if my buddy had come to me beforehand, this whole thing wouldn't have happened. But you can see we drilled it right in the center, and we even using the same threads there, and it's working good. But I don't know, there's damage to the side there. There is threads all the way along there, but on this side, obviously they're missing. So, I don't know. Now if you see this, I can put a nut on this side, and oddly enough, it looks like originally they had planned to just put a nut on this side without putting a thread over there. Okay? Because you could see that it's where's the light here? You see how they made room for a nut to go there. So there's probably opportunity to just drill this out so that, and to just put a pure nut on this side. Or we will put I don't know. There's threads there, but I don't know how much they're holding. We're gonna have to figure this one out. I'm gonna have to ask my buddy which way he wants to do it. So, because it's a gamble, right? Whichever way you do it, just a gamble, and let him gamble instead of me. So we're just cleaning the groove along here, and tool extraordinaire. We're gonna clean inside here as well. And we're gonna get to that. This is just flat. These surfaces are just, well, actually they're slightly raised, but here should be just flat. So we'll just have to be nice and easy. And we're just gonna work our way around here. This is the problem area because the hole that he drilled, my buddy, it broke the raised surface there, right? That holds the seal, right? So that's the issue gonna be going forward. There's a seal. They're all just O-ring kind of stuffs, right? Simple dimple. Okay, so we're getting to the point where I almost get the seals on. The one thing is that this seal doesn't really fit in nicely, so it's obviously stretches, but when you're bolting it together, this has to be in the right spot. If it's not in the right spot, it's going to not work well, right? It's gonna leak. So, which is a little bit weird. Anyways, that's the screw up area. You can see here that there's no raised surface for that seal. Don't get me wrong, it might still seal it, right? There's a face there. Yeah, pushing down. Yeah, it might still seal, but the pressure obviously can push, and there's no wall there, so it can actually just push it in, right? Anyways, this is the part that I cut out, right, with the milling machine.
Yeah, so a little bit of sandpaper, mostly some surgical tools, some dentistry stuff to clean it out. We're getting there, that's for sure. We're getting there. All right, so Buddy's gotten the cap bolt, the extra cap bolt. I don't know. Oh, there it is. Oh my God, I thought I lost it. It's in this bag here, stuck in the corner. Okay, and this is the old one that. Where's the old one now? This is the old one that broke. See it? There you go. So all the problems that are happening because of this. When this breaks, spuck. Anyways, we're just cleaning it up a little bit more here, and then we're going to just put it together and give it to Buddy. So I'm going to get in there with a nice sand cloth and the butt end of this file and just kind of finish cleaning up inside here. And that's about it. Maybe a little bit around here. Gotta get in there too. Okay, so as a final step, I'm going to just put a vinegar water solution in this channel here. See it? It'll receive vinegar water solution. Just fill it up here so that it'll eat away at all the calcium. I believe this is calcium deposits from water, right? And then we're just going to bolt it together. We have a little bit of, we're going to need some thermal grease there, right? Electrical thermal grease there. For the sensors, there's 2 sensors here. 2 sensors. And what else? There's a retainer clip too for the sensors. Okay, sensors go there. Right, and that's about it. I don't know what all these are for. These small little washers. I'm definitely not going to put them on here, on these little nibs, because it doesn't make any sense to put them on there. Even though you would think they would go there, they don't go there, because if water goes here, it's the seals are compromised and it's just going to flow out. So I'm not going to bother with that. They probably, I'm not touching these seals. I'm letting that guy touch those seals. I don't know what these brass fittings are actually as well. They probably, I want to say they screw into here, but they don't. They don't screw into there either. Oh, actually this one might. Whatever, I'm not touching it. That's just water. Yeah, it's just clearing up. There's just air bubbles in it. We're gonna mix a 50-50 solution of water and vinegar. It's about 20 mils. We'll do 20 mils and 20 mils. Let it sit for a couple of hours. Then we're just gonna wipe it nice and clean. Okay. And we'll let it sit for about 8 hours. There you go. So there's pits and everything inside here. It's just the way it is. It's pitted out. So we're gonna find out if it seals. Again, it's like, again, repeating. We're gonna find out if it seals. If the Harry Rosen guy gets back to us, that is. Once this job leaves us, it leaves us for good. Okay, as I said before, this is not seating well because it's too small, this gasket. So what we're going to do is we're going to put it in boiling water so that it hopefully expands about maybe 5 or let's say 5%, just with heat, right? And see if it'll fit on better. We'll put it inside our, oh my god, mug. And we'll just put a little bit of water in there and put it in the microwave. Ooh, looks like it expanded. Exciting. Exciting. It's exciting, and yes, it did expand. No, it didn't expand. Let's put it in there again. Get hot. Yes, that rubberized gasket is expanding, but I have to put it in water for longer. So let's try it again. I'm gonna have to do it really quick. Just slap it on and put on the top. Okay, we've torqued them down. The Allen wrench. It's the new one here. Now we have, just gonna guess which one goes where. Hopefully the wires are long enough to reach these connections from the machine. And here we have our silicone heat transfer compound. There we go. Dab there. That's literally 30 years old, but you can see the grease is good. This goes, we're gonna assume it goes here. This one's gonna go here. And if it's wrong, he can change it, but he can change it. And then this goes like, is there a flat spot here? I think there is. Yeah. Okay, that goes like that. This goes like this. And we're just going to torque that up a little bit. And I want to put a nut on the back end. Actually, there's the nut, but I'm not sure if I'm going to put it on. That nut was never there. I was able to torque it up like really good. Like this, I torqued it up almost as tight as these ones. So I think I'm going to leave it like that without the nut. Anyways, there it is. You want to fix or rebuild one of these things? That's what you got to do when you break the head off. Thanks for watching.